Hello, and welcome to another episode of Construct 3 explaining the samples. Before we continue, let me ask you, if you like this video, please like it. And if you like my channel, please subscribe. It's a little effort for you and it makes all of the difference for me. If you're new to Construct 3 or even using the product at an intermediate level, let me refer to a great series of templates available at the Fiverr store. They are all accompanied with comprehensive video tutorials and give a great insight into the workings of many well-known types of games. Be sure to check out the link in the description. So this Flappin' Birds game works like the well-known Flappy Bird game. You just have to click somewhere to make the bird jump upwards, and if you don't click, it just keeps on falling to the ground. Whenever it hits the ground or one of those pipes, the game will end and you can start over. So it's a very simple game and also not that difficult to make, as we'll soon see. So how does it work? So this template has got two layouts. The start layout, I'll double click it, and here we have some text in there and a sprite with the background, which contains the text, and there's also a button. It's called button play and it acts really as a button. There's a second layout, and on that second layout we've got this background here, which is fixed, and these are the pipes, and it's actually moving. The bird actually isn't moving, it's the bird's just bouncing up and down really, and the movement is actually a simulation of movement, because it's actually only the pipes going from the right to the left and those backgrounds here scrolling through the screen, and that gives you the illusion that the bird is going forward, but actually it's staying in place, and it's the pipes that's going from the right to the left. That's what happens. So what you can see here is there are two pipes here, and the pipes that are being shown when the game is being played are not here at design time, means they're not implemented here as a series of many pipes one after the other. Actually they are generated at runtime at a random place. So we'll see in a minute how that works. So these pipes here, there's just normal sprites, you can see that. And one of those sprites has got an instance variable called scored, and that instance variable is of type boolean, which can be true or false. And you can see that indicated by the fact that it's just a checkbox being true or false. You can see that also here by the type. So every instance of this sprite will have this scored marking. So for the rest, there is this bird sprite, and this bird sprite has no instance variables, but it has a behavior, being the platform behavior. Now you might ask yourself, why do we use the platform behavior here? Because we're not making Super Mario or any other platform game. No, we're actually abusing this behavior in that way that when we use the platform behavior, standard object will start to fall to the ground, like there's gravity applied to them, and search for solid objects to land on. So that's a standard behavior, and we're actually using that standard behavior to let the bird drop to the ground whenever we don't click anywhere. So that's why this has got the standard behavior, the platform behavior. At the bottom you can find two tiled backgrounds, the tiled backgrounds which are used to scroll from the right to the left, and there's a score indicator here on the top displaying how many pipes you've already passed. So basically that's it, that's what we have here. Important to know is that this has got the platform behavior, this bird, and that actually the pipes are scrolling from the right to the left. So if you go and search for what events are in play here, you can go and click on the game events, and this is where the magic happens actually. Before we do that, let's do the easy stuff and go to the start events. The start events is the event sheet linked to this start layout. So what means this button play, whenever we click the button, we just go to the game layout. That's what it does. This is a system action. Go to layout, and then we can specify a layout to give to. So effectively, when we click the play button, we will load this, and what will happen whenever we load that layout, of course, at the start of the layout, this piece of code will be executed. These actions will be executed. So the first thing what happens is the score text, the text of it is set to 0. So it's just set to 0, reset, this is set to 0. And then what we do is we set the X value of the tiled backgrounds to 0. These two tiled backgrounds here are right here, which means that effectively the X value will be set to 0, and the X value is actually the point of the origin of that value. But as you remember, these tiled backgrounds, they don't have image points. Instead, tiled backgrounds have a property called origin, and it's at the top left for this one as well as for this one. So that means whenever we set the X value to 0, the top left value will be set to the 0 coordinate. So effectively this will be set to there. That's what will happen, because the X coordinate 0 is the left edge of the layout here. So that's what will happen. There's also a variable called score. This is a global variable here, so it will be accessible from all of the event sheets, though there's only one. There's a global number, and it's set to 0 whenever we start. And then, very counterintuitive maybe, the top pipe and the bottom pipe are destroyed. So whenever there is no context for picking a sprite, and we call the destroy method on a sprite object type, all of those sprites on the layout will be removed. That means that all of the top pipes and all of the bottom pipes will be removed. So effectively this one and this one will be removed whenever we load this layout. And that's generally the idea, because we're going to start by spawning, by creating the top pipes and bottom pipes ourselves. So what we're going to do is we're going to start the game off by giving the bird a push up, because standard it will be starting to fall down, and if we were not to push it up a little bit, then it would be done fairly quickly. So let me restart this game to give you an idea on how that works. See, the first thing it did was going upwards a bit. Let's do that again. Up, it's going up. That first upward movement you can see whenever the game starts is actually this happening. From the bird, we do an action, and this action is called set vector y. And setting a vector means that it's giving an indication of a movement in a certain direction. Setting the vector to y means that it's going to be in an upward or downward direction. So for a positive y, we're going down. For a negative y, we're going up. So that's why we're setting the vector to a value called minus jump strength. So this jump strength here is 500. The higher we set this number, it's acting like a constant. You can see the global constant number. It's acting like a constant. The higher we set that number, the higher the bird will jump. But because we set this vector y to minus jump strength, it will jump up just that little bit. And we set the angle to 320 degrees, so it means that the bird is going to face upward a little bit. So, and as you see, let's do it once more again. As you see, when we click the bird is going to face upward a little bit, and as he drops to the ground, the angle of the bird will slightly change so that he faces the ground. Up and down, up. The angle of the bird is changing. How does it work? Well, actually, you can see that here on the movement section, on this movement group, you can see that every tick, meaning what we do is we rotate this 60 times dt degrees. So what we do is we rotate the bird in clockwise direction. That standard is going to be in clockwise direction, and every tick we're going to rotate it by 60 degrees, and it's actually 60 degrees per second, because this is the number of degrees, but we multiply it with dt, and dt is the delta time, is a constant to make a construct frame rate independent. So as the frame rate standard is going to be 60 fps, so 60 frames per second, dt, every tick will be 1/60th of the frame rate. So it's going to be 60 divided by 60 actually. So every second we will rotate by 60 degrees. That's what the logic and the math behind this is. So it's actually constantly rotating in clockwise directions at 60 degrees per second, but whenever we click, this action is also going to happen. So this action that happens the first time we start the game is also happening whenever we touch the screen or we click. Yeah, that is happening again. So it's rotating by 60 degrees per second, but when we touch up, it's going to go to 320 degrees again and start rotating again. And when we click, it's going to 320 again and start rotating again, and stuff like that. So that's how this actually works. So then there's also some logic to restart the game. Restart the game whenever we're overlapping this tile background, and this tile background is actually this one here. When we're overlapping, that means that the bird has hit the ground and we have to restart. So the only thing we do is we go to the layout called start, or whenever we're overlapping a top pipe or a bottom pipe, we also we also go to start, and whenever we would be out of the layout, somehow we also go to the start. So how do we score? So the first time each bottom pipe goes past the bird to the left, we add 1 to the score. So whenever what we do here is we check the x-coordinate of the bottom pipe. That's what we do here. Parameters for bottom pipe compare x. Whenever the x of the bottom pipe is smaller or equal to the pipe, and the pipe has not been scored, that means that the pipe's instance variable scored, which I mentioned a bit earlier, is not set. What we're going to do is add 1 to the score, set that score on the screen, we set the text on the screen, and then we set that variable on that bottom pipe. So next time we evaluate this section, next time construct checks if that x value is smaller than the bird's x value, the score isn't added once again. That's why this check happens. If we were not to do this, if we were to comment this out, that means that whenever the bird passes some pipe, the score would continuously add on, because no matter the x-coordinate of that pipe would be forever less than the x-coordinate of the bird. So that's why it is checking that. All right. So for the background, as you remember, the forward movement of the bird is actually simulated by the opposite movement of everything that's coming from in front of him, so the pipes and the background and stuff like that. But as you can see, these tiled backgrounds here are not infinitely long. They are only, in this case, 1107 pixels wide. So whenever this tiled background is going beyond that threshold where it would move out of the screen, move off of the screen, then the x-coordinate of that tile background is reset to 0. So that's what we do here. Whenever that x-coordinate is smaller than -560, and -560 is somewhere like over there somewhere, minus 560, somewhere over there, you can see that here, then all of a sudden it becomes 0 again, and then we move there, and then it becomes 0 again. That's what it does all of the time. So that simulates actually the endless the endless stream of tiled backgrounds actually, because we're constantly checking that x coordinate, and whenever we're smaller than that value here, minus 560, we go to 0. The same applies for tiled background 2 actually, only it's a different number because it's a slightly smaller tiled background. So also on every tick, we're going to constantly set all of the bottom pipes and all of the top pipes x coordinate to itself's x coordinate minus something called a scroll speed, and the scroll speed here is also a constant here. So the higher we set this number, the faster these pipes will go. So we subtract the scroll speed from the x coordinate of the pipe. That means that the pipe will gradually go from right to the left, and we also always need to take care that we multiply a value whenever we do something on every tick. We need to multiply this by dt to be actually frame rate independent. It's very important. So we do that with the x of the bottom pipe and the top pipe. And what we do here with the tile background, we do exactly the same thing. We scroll it to the left. And so you see whenever that has happened, the next tick, we will check again if this is smaller than 560, and we set it to 0, and then the next tick we're going to set it to minus the scroll speed again. So it's going on forever. So whenever we check if a top pipe is smaller than minus 50, which means that that pipe somehow has moved before the x coordinate here. So this code has been going on for long enough, and it's constantly subtracting the scroll speed from the x coordinate, constantly doing that, and at some point in time that x coordinate of that bottom pipe or top pipe for that matter is going to become less than minus 50, and at that time we know that that pipe has already moved off screen, and we don't want it to take up any memory anymore in the game. So that's why at that time the top pipe and the bottom pipe are destroyed. And the last thing we wanted to do, of course, is create the top and the bottom pipes every so many seconds. And you can see here there is a system event called every x seconds, and that x here is in this case also seconds per obstacle, a variable. You can see here seconds per obstacle, meaning 1. Every 1 second we're going to create a top pipe and a bottom pipe rather. And we're going to do that on a certain layer, in this case layer 0, because this game only contains a single layer. And then we need to specify at which x and y coordinates we're going to put that. And we're going to put it at the fixed x coordinate, being 440, and 440 will be somewhere over here. You can see that here 440 is about there-ish. Yeah? I'm trying to mimic 440 here in the position, so it will be right off screen. It's going to be created at that coordinate, but the y coordinate we're going to have a randomization, and the randomization function can have a number of parameters, and if you specify 2 parameters, a bottom and a top threshold, or a top and a bottom threshold, it's going to be from somewhere between 50 and minus 250. Same here, this is going to be the top pipe y, which was something we just specified at random, plus 750, but at the same x coordinate. Why do we do this? Okay, we can make the top pipe somewhere random between 50 and minus 250, but the space between the top pipe and the bottom pipe needs to be the same, of course, because otherwise the gap for the bird to fly through might be too small or too large. So that's why we start from the y coordinate of the top pipe, and we just add a fixed number, 750. If we were to enlarge this number, the gaps would be greater of course, and if we were to decrease it, the gaps would become smaller. What we do is we move the text to the top of the layer, because otherwise the pipes here would overlap with the score text, and the bottom pipe we will initialize its instance variable called scored to false. So next time we move over the bird goes past the bottom pipe, the score will be enlarged, will be increased. So that's about it. This is how this template works. As always, please like and subscribe, and see you next time.